So today we're going to talk about section 4.5. Please don't tell any of your friends. These are the super secret notes. And we're going to talk about sines and cosines. And when you talk about sines and cosines, you need to understand that sines and cosines are something they call periodic functions. Periodic functions means that they repeat themselves forever. Okay? And every so often the same thing occurs. And these periodic functions have to do with actually like electricity. So all your sockets here run on 60 hertz. If you go to a different country, they don't run the same wavelength. And if you ever have seen an oscilloscope, like when you watch those doctor movies and you see the little thing going blip, blip, that's sine cosine graphs. Okay? And they talk about a period and amplitudes and all these other things we're going to talk about today. So there are two basic graphs that we're going to talk about today. I'm going to highly focus on one. And the reason I'm going to highly focus on one is because they're both exactly the same, just shifted. And if you remember when we talked about our absolute value graphs, those V graphs, and I said if you understand how this V graph works with moving left and right, up and down, stretching, shrinking, flipping over the x-axis, that kind of stuff, you understand all functions because they all work the same. The truest same for sine and cosine. Everything's exactly the same except for where it begins. And that's it. And that'll make a little more sense as you see it. So the first thing I'm going to do is I'm going to graph the sine graph. What I want you to do is copy down what I have. In each of these sines and cosine graphs, we're going to have the beginning point and 4 other markings, or a total of what they call 5 critical values or points. In a normal, quote-unquote, sine graph, our normal period, or what it takes for one cycle to occur, is what they call 2 pi. And you can kind of see how these radian things that we learned about last unit are going to be kind of important. And I'm going to break this graph up into 4 locations. If I break it up into 4 locations, the halfway mark is half of 2 pi, which would be pi. Halfway to pi would be pi over 2. And in between pi and 2 pi is 3 pi over 2. Bless you. And then on the vertical axis, which we usually call the y-axis, I'm going to put down -1 and 1. And what I want to show you are 2 graphs. So I'll wait for people to get caught up and then I'll draw those. The first graph that I want to talk about is the sine graph. So I'm just going to write down y equals sine. And they like to use the letter x. You could use theta, you could use t, you could use q. I don't really care. Oftentimes in our notes and in our tests they use x. And the sine graph looks like this. There are 5 critical values. 1, 2, 3, 4, 5. If I connect these critical values in a wave motion, it looks like this. Thank you for the 5 people with a sense of humor. Nice. This curve with 1 mountain and 1 valley is the sine curve. Now this curve doesn't stop between 0 and 2 pi. It goes on forever to the right. It goes on forever to the left. But for you to see 1 mountain and 1 valley takes 2 pi normally. Okay, that's the sine graph with 1 period, 1 cycle. And I'll show you it with more than 1 cycle. I just want to let you know what's going on. Second, I want to show you what the cosine graph looks like side by side. So y equals the cosine of x. There are also 5 critical values between 0 and 2 pi. 1, 2, 3, 4, 5. Also, with a mountain and a valley However, in this case, the mountain is split because the graph of the cosine is what they call out of phase with the sine graph by pi over 2. It's shifted pi over 2. Next page. I am now only going to concentrate on the sine graph because, as I told you earlier, cosine works exactly the same. But instead of starting down at the center line, or what I call the midline, we started at the top of the amplitude for the mountain with the cosine. That's the only difference. Everything's shifted over by one dot. So I'm just going to work with the sine so that I can try to show you how all the different things are affected as you change things, and then we'll go from there. So you're going to need one big graph, and I'm just going to do like we did with our absolute value. I'm going to draw a bunch of graphs, and we're going to talk about stuff. First of all, I want you to know that the general form of a sine graph looks like this. Y equals A sine BX plus C plus D. And it might be minus C, I don't know. Basically, I want you to know there's an A, B, C, and D, which are all numbers. And each one of these things, these A's, B's, C's, and D's, affect a different part of the graph. So as I draw this comprehensive graph, here's what I want you to do. Just like before, we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to go with -1, -2, and -3 for the y-axis. And to start out with, I'm going to draw the normal sine graph, and then I'm going to transform it, and I want you to try and figure out what each of the letters are doing. So now you see on the graph, this is the graph that we're going to start with. We've already shown it on the previous one. This is just the normal sine graph. Notice how the amplitude is 1 because the mountains are 1 unit high and 1 unit low. The period or the cycle is 2 pi because in order for me to see one mountain and one valley, it takes 2 pi units. What happens when I do this? What's happening to the graph?
It stretches vertically.
Okay, let's use some words that I've already talked about.
A is 2.
What?
A is 2.
A is 2, I like that. Amplitude changes. It's 2. Okay, so the letter A has been changed. It is the amplitude that is changing. Here we go again. What's that going to do? Flip it, just like every other graph we've ever done with a negative in front. All it does is flip it. So this negative sign is actually associated with the A because it's -1. So I'm just going to go like this. So now in the orange graph on the board, we have y equals sine x plus 1. What do you think happened to that graph?
It goes up. It shifts up 1.
Shifts up 1. So now, I look like this. Remember, everything's being compared to the red graph. The red graph is the original sine graph. So everything is compared to the red. What I want you to notice is that that letter was letter
B.
D, as in duh. And maybe you don't know this, but I use the word midline. Because if I look at the black x-axis, everybody take a look, stop writing for a second. Look at the black x-axis. You see the red graph go above a mountain and below a valley off of the black x-axis. That whole axis has now shifted up 1 unit. And if you look at the green dashed line now, kind of your new x-axis, the orange graph is 1 unit above and 1 unit below that new midline, 1 unit above where it was before. Now start writing again. In this next one, I have the following. Y equals the sine of 2x. Watch carefully. Notice that in the normal red sine graph, stop talking, thank you, that it took 2 pi to get done when you had y equals sine x. Now that you have y equals sine of 2x, you're getting done with 1 mountain and 1 valley in pi for the period. You're finishing your mountain and valley in half the time because you're going twice as fast. That b that you see with the x affects your period or your cycle speed. So the number there is affecting it.
Oh, I get it now.
The b affects the period. And I'm going to talk more about that in a little bit. Hey. Last one. And then we're going to do something special.
Take a nap?
You can definitely do that. That says x minus pi over 2 in the parentheses. And here's what happens. Shh. Look at the red graph, and then look at the pink graph. What happened from the red to the pink? Shifted forward pi over 2. The stuff in the parentheses shifted the graph pi over 2 to the right. Or just pi over 2 would be fine to say. The way that you find your shift, because shift happens, is you set the stuff inside the parentheses equal to 0. And the C specifically